It's your Friday Chuck Channel math lesson, and I am so glad you're here with me, Miss Patsos, Miss Baumgartner, Miss Williams. It's a great day. It's beautiful out. Make sure you're getting your exercise and doing your PE. Hey, you're built-in recess. Make sure you are going out and playing. So, we are going to continue on our geometry unit, and I will tell you, I am super sad I don't get to do this with you because we agree as a team, this was our favorite unit to teach, and this is so much fun, and we wish we could do hands-on with you, and if we get back together, which I hope we will, we'll do some of the fun stuff together, okay? All right, starting with our standard, we're going to recognize, draw shapes having specified attributes, such as a given number of angles, given number of equal faces, identify triangles, quadrilaterals, pentagons, hexagons, and cubes. Today our question is, how can I cover rectangles with equal size squares and count to find the total number of them? I'm going to give you a great big hint. It's not sit there and count the squares. No. We are going to take our rectangles and make arrays in them. Now, we have made arrays before. We've made arrays, oh, look at that. We've made arrays with columns and rows. Rows go out, columns go up and down. Row, row your boat, remember? So, we're going to take a look. How many squares does this take to fill my rectangle? Okay? There are 6 squares. There are 6 second grade teachers. Each one of us wants a piece of the Hershey bar. And I don't want Miss Baumgartner to get more than me because I really love chocolate. So I want an equal share, okay? Now, way back in first grade in kindergarten, you could actually just count the squares. 1, 2, 3, 4, 5, 6. But you guys are big second graders now. You're big. You're so big. And I bet you have grown. By the time I see you next, you're probably going to be up to my shoulders, or you've even passed me. So you've grown. So we are not going to sit there and count squares. We are going to use our background knowledge and our prior knowledge to use our arrays and our rows and columns to add, okay? So, in our example over here, we're going to add the rows. Well, remember, our rows go this way. Our rows go this way, okay? So, how many do I have in my first row? Count with me. 1, 2, 3. So, I have 3 in my first row. How many do I have in my second row?
1, 2, 3.
3 in my second row. Here's a big hint. Should be the same number. Then, this is where we have our rows, 3 and 3. So I know that 3 plus 3 equals 6. So I don't have to sit there and count 1, 2, 3, 4, 5, 6. It's the same thing when you get a bigger square, there's going to be 25 pieces in there. You're going to get lost. And so it's better to know I can do a quick add, okay? Remember, our columns go up and down. They hold up my fortress, okay? How many do I have in this column? 1, 2. How many do I have in this column?
1, 2.
How many do I have in this column?
1, 2.
So I have 2 in each of my columns 3 times. So 2 plus 2 plus 2. And that is the same number. Let me give you a great big hint. These should match. My rows and my columns, my sum, the answer to my addition problem, my sum should match. Because if I get a different number here than here, I did something wrong. So I know when I'm doing my math tonight, what I am doing is I should have the same number, okay? So, now, I want to look see if I can get this over here. There we go. Okay. We're going to look for patterns. Mr. Corey puts square tiles on the kitchen floor. The square tiles are all the same size. How many equal squares are there? Write 2 equations to show the total number of square tiles. Okay? So we clearly want them all the same, because if we had different tiles in my kitchen, that would be just crazy. So we're looking at our rows, and our rows go across. So how many are in my first row? Ready? Let's count.
1, 2, 3, 4, 5, 6, 7.
7. And now I am doing it again. 2,
3, 4, 5, 6,
7.
7.
1,
1, 2, 3, 4, 5, 6, 7.
Miss Chubb, this is repeated addition.
It is repeated addition. You are so correct. And that's going to set you up for multiplication. Pretty exciting. Ready? 1, 2, 3, 4, 5, 6, 7. And our last one. 1,
2, 3, 4, 5, 6, 7.
Now, we have 7 plus 7 plus 7 plus 7 plus 7. Okay? Well, instead of counting 1, 2, 3, 4, 5, 6, 7. Okay? 7, 14, 21, 28, 35. So we have, if we count by sevens, 7, 14,
21,
28,
35.
35.
So all together, I have
38
sorry, 35 tiles. Sorry, I went 28, 30, I'm sorry. All right, so we have 35. Do you remember what I said on the front? That my rows and my columns should match. They should be equal. So this little guy and this little guy should be the same, okay? Let's see how we can make some math magic here, okay? Ready? Now we're gonna go up and down, because that is our columns. Very good. 1, 2,
3, 4, 5.
Ready?
1, 2, 3, 4, 5.
Ready?
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
And
1, 2, 3, 4, 5.
Now, we can count by fives. Ready? 5, 10, 15, 20, 25, 30, 35. Because I am counting 5, 1, 2, 3, 4, 5, 6, 7 times. I am counting 5, 7 times. So, therefore, I'm going to go 5, 10, 15, 20, 7 times, okay? So my answer is 35. Now, I didn't have to sit there and count each one of my squares, did I? No. I used repeated addition, and I used my knowledge of arrays by rows and columns to find how many squares, equal squares, are in my rectangle. Okay? Now, let's take a look at this question here. 10 friends want to equally share a rectangular pan of granola bars. Show the rectangle in 10 equal pieces. Okay? How would I do that? How would I solve this problem? I can't, if it was chocolate, again, I would be making sure that I have an equal share, not any less than Mrs. Baumgartner or Miss Williams, because it's going to be chocolate. But looking here, we want to make it equal. So I can't make this skinny piece here and somebody get a big chunk here. That's not going to happen. It's not going to fly with me. So how am I going to make a rectangular pan of granola bars in 10 equal pieces? Let's think about our strategies. I'm going to look up here. How did they break it up? Well, I could divide it which way? There's several different ways I could do it. I could make 10
Columns.
10 columns, very good. 1, 2, 3, oops, 4.
5, 6, 7, 8, 9.
Is that 9?
No, no,
That's-
that,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's too many.
Edited. We spliced it off, guys. All right, so we could make it this way. How else can we make it? Can we make it in squares like a Hershey bar?
Sure.
How could I do that? How could I do that? How could I draw, how could I make it, there's like a Hershey bar. We made it like a Kit Kat bar. We made it look like a Kit Kat or Twix. Hershey bars have equal things. So how can I make it look like a Hershey bar? Think rows and columns.
5 columns.
Ooh, okay. So I'm going to use a different color, so we know we're using a different way of doing it. So, 1, 2, 3, 4, 5. And then
2 rows.
if I do 2 rows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do I have equal? Yes. I know it's not the most perfect drawing. I'm sorry. You know Miss Chuck's art skills are leave something to be desired. I'm sorry. But everybody gets the same amount. Okay? Now, you did very good with that question. That was a higher order thinking question. That means it was kind of a challenge one. Now, I want you on the video to kind of do this one along with me. Okay? Count the equal squares in rows and columns of the rectangle. Then we're going to use the cards on the side, okay, to write the missing numbers in here. So you're going to use 4s, 12s, and 3s. Where, using this diagram, am I going to put my rows? What number am I going to put with my rows? So I'm going to give you just a minute. I want you to maybe at home draw me a figure of this on a piece of paper, okay? On a scrap piece of paper. Use your pencil and draw. Now, where am I going to write? What number will I write for the rows? Rows go which way?
Side to side. A row and a bow.
Yes, row and a bow. We go side to side. So, is this a row?
No. It's a column.
Is this my row?
Yes.
Yes. So what number goes in my row?
3.
3. So I'm going to use, it says use the tile, okay, use the card. So I'm going to use my little card 3 and write my 3. Now, what's special about this? We are using
Repeated addition.
repeated addition. So is this going to be 3 plus 4 plus 5?
No.
No, it's going to be straight 3s. 3 plus 3 plus 3. Because look at, we have 1, 2, 3, 4 3s going across. Now, let's look at my columns. My columns go
Up
Up
and
and
down.
up and down. They got to hold your structure up, okay? So, how many are in my columns?
4.
4, that's right. So I'm going to use my 4 tile. I'm going to use my 4 tile here. So I have 4, and I'm going to use repeated addition to go across. So it would be 4 plus 4 plus 4. I have 3 columns, 1, 2, 3. I have 3 4s, 4 plus 4 plus 4. So I've used a 3, I've used the 4. I have a fancy number 12.
Our sum.
That is our sum. Our sum is the answer to our addition problem. And remember, I told you these two numbers should
Match.
match. Okay. You are now going to go on iReady and do your 30 minutes of iReady. Then you're going to go to your Pearsontile. And in your Pearsontile, you have your Envision. You have your visual learning, your daily math, and your independent practice page that looks a lot like that. Okay, so your 3 things plus your iReady. Should you have any questions, contact us. We are happy to help. We love you. We can't wait to see you. And we hope you're growing and getting stronger and your brain is getting stronger with all of this math we've been teaching you. We love you.